One of the skills you need to be really good at for your AP exam and this course is being able to read outputs for least square regression lines from different software programs. So they're all going to look a little different depending on the software that generated them. Here's one example that is taken from Khan Academy. It says Desiree is interested to see if students who consume more caffeine tend to study more as well. She randomly selects 20 students at her school and records their caffeine intake in milligrams and the number of hours spent studying. A scatter plot of the data showed a linear relationship. This is computer output from a least squares regression analysis on the data. So you're going to start by scanning what's given. This word constant and coefficient, I'm looking at the intersection here. So this is the coefficient on my constant term. Well, your constant term in your least square regression line is your y-intercept. So the 2.544 would be my A value. And then I'm told that the coefficient on caffeine milligrams, well, this is telling me then that this is my explanatory variable. And here is the B value, your slope. So I'm going to write my regression model. I'll put 2.544 as my A, my y-intercept, plus 0.164 times in context caffeine. And that is equal to the predicted, well, I've got to go back to my word problem, the predicted hours studying. So I'm going to write HR. Maybe I should have put study time. And I put my hat over it. So the predicted hours studying is equal to that. The next thing we're asked is, so what's the correlation coefficient? And I want to tell you one or two things here. So as I scan this bottom, I see S, that's going to be the standard deviation of your residuals. R square, well, that is, your coefficient of determination, and R squared adjusted will not be used ever in the AP course. Not in AP, all right? So just get in the habit of crossing it out. It's usually there as a distractor in your multiple choice. Somebody always picks it as being one of the right answers, and it's not right, okay? We won't use it. So I'm going to have to get my correlation coefficient, which you should know is R, by doing R squared. So all I need to do is, take the square root of R squared, or the square root of need to change it to a decimal, 0.60032. I put that in my calculator, and I get that, let's see, R is equal to, I should probably say approximately equal to 0.775. One more thing you need to think about. Is it positive or negative? Because when you take the square root on your calculator, you will always be given a positive value. And this is where kids make a lot of mistakes. How do you know? You look at your slope, okay? So your slope is telling you whether you've got a negative or a positive association. My slope is positive here. It was 0.164. So I do have a moderately strong positive linear association between the milligrams of caffeine consumed and the hours spent studying. If you had a negative value right here, you would need to put a negative value for your R, okay? Another type of question you might be asked is, so how large is the typical prediction error when using this model to predict study time from caffeine intake? So prediction error, that's really talking about your standard deviation of your residuals, or your S value. So your residuals, how far off are you? When we say what's the typical, now we're talking standard deviation. So I would say it's typically about 1.532, get your units on it, hours.